basic quantities and derived quantities. Derived quantities, SI base quantities and SI quantities, or their units are SI base units, SI base units and SI units. Now, we are discussing Newton is an SI unit and its SI base unit is kg meter per second square, and this is very important unit to remember. If you remember it, it will make your life easy in exam. One more is joule, which is kg meter square per second square. Now, if you remember joule, then making a unit for watt, which is joules per second, is very easy. Just divide the joule with second. It will become kg meter per second cube, which is watt. So if you remember joule, then making the unit for power is very easy. C stands for coulomb, and coulomb is AS, ampere second. So these are must remember units. If you remember more, it is good. For example, if somebody remembers that Pascal is kg m minus 1 s minus 2, it is good. But even if you don't, you can easily make it in the exam by doing, because you know Pascal is for pressure and pressure is force over area. So you know it is kg meter per second square divided by meter square. You will get kg minus 1 s minus 1. So these are the units you must remember, must. Otherwise, you will be just finding unit all the time in the exam. Okay. Now, this is the introduction of basic unit and derived unit. Quickly moving on the next topic, that is errors. Errors are actually differences. Difference of what? Difference of measured value to other measured value, or difference of measured value to true value. There are differences. And whenever we say that one value is this, actually it is always within two different values. So errors are called by, or produce, can be divided into systematic errors and random errors. Systematic errors are due to instrument. If there is some problem in the instrument, it will cause systematic error. These errors have fixed, predictable value, can be fixed by simple addition or subtraction. These errors affect accuracy. Now, what are random errors? Errors due to human limitations. Like, let me give you an example for previous one. Example will be zero error. Now, error due to human limitations. These errors don't have fixed value or sign. They can be positive and negative, more or less. They can be uh, same every time. They can be different every time. We cannot predict these errors. They have unpredictable. To fix such errors, we use statistical or graphical methods. Now, take average of many readings, draw best fit line. I hope you are familiar with these techniques. Example can be for this one. Human reflex action delay. We see something and we do something. There is always a thinking time in between. Okay, as systematic errors were affecting accuracy, what do you think random errors do? Random errors affect precision. Now, I have used two words. I need to explain them. One is accuracy and other is precision. What is accuracy and what is precision? Accuracy is closeness between measured value and true value. It is accuracy is closeness between measured value and true value. This is disturbed by systematic errors. Now, what is precision? Precision is closeness among measured values. If measured values are in small range work is precise. So if somebody is taking readings and all of the readings are within a very small range, then it means his work is precise. So accuracy and precision. Very commonly, examiner asks for the definition of these things. Now, error is done or uncertainty is produced. If there is always an error in making a reading, so it means that the thing that we have measured is not, we are not 100% certain that the value is what we have measured. So this is where uncertainty is born. We write quantity plus minus its absolute uncertainty. So it is quantity plus minus absolute uncertainty. What is absolute uncertainty? This uncertainty has same unit as measured quantity. So absolute uncertainty should have exact same unit as measured quantity. It should have only one significant figure. It should have only one significant figure. One, when we round off the absolute uncertainty to the excuse me, single significant figure, then we round off the quantity round off the quantity to appropriate number of decimal position and significant steps. After this, we have and remember, for addition and subtraction, if x has an uncertainty of delta x and y has an uncertainty of delta y, then x plus minus y, if you add x or subtract x, in both cases, the error will be delta x plus delta y. Okay. Now, next thing in this list is that you must know is fractional error or uncertainty. Fractional uncertainty. Fractional uncertainty is absolute uncertainty divided by measured quantity. So fractional uncertainty is delta Q over Q. Why it is important? If we have a formula that has multiple factors in it, if A equals to B, C, D with powers M and N, then remember this is actually the product of the formula. And these are factors of whether they are multiplying or dividing. We will consider them as same. So remember, this is a very important line. Fractional uncertainty of product equals to sum of fractional fractional uncertainties of factors. So what does that mean? Listen, this means that if we do delta A over A, which is the fractional uncertainty of A, this will be equal to delta B over B plus delta C over C plus delta D over D, where we need to multiply this thing with M and this thing with N. Okay, so if any of these things is missing, we can find it out using this formula. Normally what happens is that we already know the value of A, we know B and its uncertainty, C and its uncertainty, D and its uncertainty. This is the normal format of the question as it appears in exam. So all these things and their uncertainties are given. A is already calculated in the previous part, but uncertainty is missing. And then we use this ratio or formula, this whole setup to find out this delta A because already A has been calculated in the previous part. Okay. So we can continue from the same point tomorrow. Allah Hafiz. Okay, I will finish this video because a small thing is left. Now, percentage error equals to fractional error multiplied by 100. So remember, percentage uncertainty of product equals to sum of percentage uncertainties of factors. So if you are looking for percentage uncertainty of A, it will be percentage uncertainty of B plus M times percentage uncertainty of C plus N times percentage uncertainty of, actually I was supposed to write D over here, D. Okay. Once we calculate the percentage uncertainty, we can use that to find out the original uncertainty of the, or absolute uncertainty of the quantity as well. Okay, this is all that we need to know about errors, uncertainty, basic and drive units, and accuracy and precision. In this lesson, we completed all these things. Tomorrow, we'll be solving past paper questions regarding this topic. Thank you very much for today.
Thank you, sir.